Okay, now you're going to solve quadratic equations using the square root property. So what are we doing here? Well, first of all, what is a quadratic equation? A quadratic equation is an equation that has a variable squared in it. We have actually already done this when we did our Pythagorean theorem, because we came down with things like the side squared or the hypotenuse squared was equal to like 144, and you did x was equal to the square root of 144, which was equal to 12. And so we've already done this form of a problem, but in a very more precise and simple way. Because we were dealing with an actual measurement, we only considered the positive of that square root, because a measurement has to be positive. So now we're going to look at it in a little bit different way. We're actually going to look at it as both possible roots. So if we have an x squared is equal to the number 9, well, you know that 3 times 3 equals 9, and negative 3 times negative 3 also equals 9. So by this we can see that we actually have two potential answers to this problem, which is exactly right. So we have x is equal to 3 or x is equal to a negative 3. So we have two answers when we have a quadratic equation. And so this one we could do in our head, because we knew that 3 times 3 was 9 and negative 3 times negative 3 was 9. But now we're going to look at ones that are maybe a little more complex. How about 2x squared equals 50? Okay, well, let's start with x squared equals 50. So now, what is our process? First of all, your squared part must be isolated. So, number one, isolate the squared part. Okay, which we've done. Now, remember, the other was just simply taking the square root. But when we take a square root, unless we indicate different, the only answer is positive. So we're going to have to indicate both the positive answer and the negative answer by writing plus or minus in front of my square root. So now this breaks down into 2 times 25, and 25 is 5 times 5. Thus, this is equal to 5 times my square root of 2. So you're using what you've just finished doing. So x then is equal to plus or minus 5 square root of 2. Okay? So this is pretty straightforward. It's just simply make sure you isolate the square, and then 2, do the square root to undo the square. And don't forget the plus or minus. Okay, so that's our second step. And then 3, simplify. And 4, continue solving. And you will see this happen in the next problem as we continue solving. Okay. X plus 3 squared equals 25. Okay. As you can see, my x plus 3 is inside my parentheses, so this whole thing is squared. So it is isolated. So that means I am going to undo my square by taking a square root of both sides. And remember, in all solving equations, whatever you do to one side, you have to do to the other side. So this means this is equal to plus 5 or minus 5. And since that is an integer number, to make sure that we get both answers, we're going to actually end up writing this twice, because the x plus 3, this undoes that, leaving me x plus 3 is equal to plus or minus 5. So I'm going to write x plus 3 equals 5, or x plus 3 equals negative 5. As you can see, I have to solve with both answers. So subtract my 3, and I get x is equal to 2. That's one answer. Over here, we're going to subtract the 3, and we end up with x is equal to negative 8. Okay? And that gives me both of my potential answers for this equation. So this is really important to remember that plus or minus. And as you see, we had to continue solving after we simplified our radical. So simplify the radical, and then continue solving. Okay, so let's look at another one. Let's look at this one. How about 32? Okay, again, my square is already isolated, so I'm going to undo my square by taking my square root of both sides. And my square undoes my square root undoes my square, leaving me with x minus 4, which is equal to, this is plus or minus, this is going to be 2 times 16. 16 is 4 times 4. So this gives me 4 comes out of the house, and I have a square root of 2 that stays inside the house. So I have x minus 4 is equal to plus or minus 4 square root of 2. So now I'm going to add my 4. And notice when I add my 4, what happens? I don't put it over here underneath my 4 square root of 2. Why? Well, it's because they are not like terms. And so therefore, I have x is equal to 4 plus or minus 4 square root of 2. And that would be the answer. It just gets simplified like that and stops right there. So now let's do one even more complex. Okay, on this one, my square is not yet isolated. So the first thing I'm going to have to do is isolate my square. So I'm going to add my 6 to both sides. And notice it's a like term, so I wrote it underneath, and I still have my x plus 2 squared is now equal to 20. Now it is isolated, so now I'm going to undo my square by taking the square root of both sides. So I now have x plus 2 is equal to the square root of 20, and this is 4 times 5. 4 is 2 times 2. So this is going to be, there's my 2 of a kind to come out of my house, and that's my 1 without a match that stays inside the house. So I have plus or minus 2 square root of 5. Now I'm going to subtract my 2 from both sides, and notice again, these are not like terms because this has a square root of 5 with it. So x is equal to negative 2 plus or minus 2 square root of 5. And notice that when I add or subtract in my solving, I keep it in front of the square root term because it's the square root term here that is your plus or minus. And notice that the only time I went ahead and solved it all the way down was when we actually ended up with an integer when we did our square root. The rest of them we end up with a more complex expression. And so, almost done. One more of these, and then we'll look at some imaginary ones. Simplify it. Let's go, what number do I want? Let's see, adding 10 to it, let's go 40. Okay, now my square is not isolated, so my first step will be to isolate it by adding my 10 to both sides. And now I have 2x plus 5. That whole quantity squared is equal to 50. Now undo your square root and do the same to both sides, and don't forget your plus or minus. This undoes my square, leaving me with 2x plus 5 is equal to, the square root of 50 is going to be 2 times 25. There's your 5 times 5. So this is plus or minus 5 square root of 2, because that's what's all alone and left inside the house. Now subtract your 5, and again notice they are not like terms, so I cannot add this to this. I will have to write it as negative 5 plus or minus 5 square root of 2. But I still have 2x over here. So now undo my multiplication by dividing by 2, divide this whole thing by 2, and we end up with x is equal to negative 5 plus or minus 5 square root of 2, all of it divided by 2. And as you can see, if you have done the quadratic formula in the past, this answer is very similar to an answer that you would get using your quadratic formula. So all this is done simply by applying the square root property. The next video will deal with it as I imagine.